Dobar dan. Yeah. Well, that's what I know. I also know how to say voda, pivo, vino, right? That's the most important thing so far. Well, that's my Twitter handle in case you want to tweet with things about my talk. Otherwise, I'll give you a different one. The sponsor slide. And so a little bit about me. My background is from development side. So I work at CloudBees, the company doing like Jenkins enterprise editions. So who is using Jenkins today or using on their team? So pretty much everybody. You should tell the other people that they should use it. So I'm focusing more on the part of scaling Jenkins, like running it at big enterprises, large scale, continuous building, and so on. I did some things in open source. Who's used or is using Apache Maven? So some Java people here. You love it or you hate it? It's one or the other. You cannot be neutral about Maven, right? So I have contributed to multiple Apache projects, Eclipse Foundation, open source, Puppet, whatever, a bunch of things. And I'm also a member of the Google Developer Experts through the work done on Kubernetes and containers. So we're going to talk today about microservices. So an explanation or an introduction, it's what's the difference between microservices and other like service-oriented architectures and so on. So there's some definitions mainly from Martin Fowler. So how do you develop an application that is microservice or can be called microservices? It's small parts or small services, and they communicate between each other with lightweight protocols. So HTTP typically. Maybe today gRPC, something like that. And these services are built around business capabilities, okay? So the definition is you have a business goal that is served by each microservice. So it's not stack slicing based on the stack, like database here, front end here, but vertical slide in the sense that, I don't know, like you want to do a checkout card for a website. That's the business unit, right? So a microservice would cover all that functionality. And this would be independently deployable. That's very important if you want to go about continuous delivery. Each of these pieces can be deployed independently, released independently, and so on. Hopefully by fully automated systems. By the way, you can ask me questions anytime. Not him, but everybody else can. So how is an application composed with a microservices architecture? So you have separate processes, so it's not longer in process, so you have definitely separate processes talking between each other, deployed independently. Minimal centralized management in the sense that you don't need to have something central that controls everything, but they are totally independent, and you automatically deploy them. Compared to monolith, does the opposite, like traditional name for what's not microservices? Instead of the scaling by having more and more servers that run the same thing over and over, you just have these microservices running in a subset of servers. So you can have a microservice running 4 or 5 different instances, but you don't have to, you can mix and match, basically. You can have some service running across a number of nodes, and then another service also running partially in those nodes and running on other nodes. So it's not like I scale by creating copies of the same server, but I have a cluster, and then I deploy my microservices in there. And I'll go into more detail on how you can do that later. Another characteristic is the components are services versus libraries. So you have these services talking to each other. It's not that you just add more libraries to one application. And around business capabilities, as I mentioned before, this allows you to have, or forces you more, to have cross-functional teams. So you don't have a team that is like backend, another team that is database, and another team that is front-end, but you have teams that work in a business unit, and those teams cover everything from front-end to database to deployment to maybe server management. It depends on how you want to split it. And they focus on products and not projects, in the sense that when you release this, like let's say you have to release a version of these services, you don't release it and you say, okay, I'm done, right? And move on to something else. And this is a common problem we see with maybe some outsourcing companies or people that are not involved in the business value of products. With microservices, you focus on the product part. It doesn't mean that you cannot move from one team to another, but it means that there's a team that is going to focus on shopping cart. And once they release something, they will keep that, making sure that that's running over and over the time, right? So you have the continuous operation of that service. This is the ongoing maintenance, the ongoing delivery of new features. That's the responsibility of that team. So it's not like, I'm up to here, then I'm done. It's like the continuous management of that product. Decentralized governance, which means you can have multiple services running on different languages. You can have some services running on Java, some services running on Go. You don't care about the service, about the language you use, because basically they talk between each other using APIs. And there's, Amazon is one of the companies that is pushing or doing this microservices approach, where when you load a page on Amazon, it's like composed by 2,000 services that are interoperating in the background, and each team is responsible for one of those services. So when you see an Amazon page, there's no one team that builds that page. There's a lot of communication involved in the backend. And they came with this phrase that you build it, you run it, meaning that each team that builds one of these services are responsible of their own selections of choosing of language, database, whatever. So you are fully responsible of, that team is fully responsible of what the end product is going to be. So if something breaks, they have to fix it. So they have to be aware of what their elections are. And decentralized data management, so it's no longer that you can just say, okay, now my application is going to use this database. Now you have multiple services. Every service can choose their own backend, right, or database. That's not to say that you can have like a sprawl of like somebody running Oracle, somebody running MySQL, somebody running something else. That could happen, but obviously there's got to be some reasoning behind your elections. What this means is some service may decide to use a SQL database. Some service may decide to say, well, it doesn't make sense for us to have a SQL database. We need a key value database, or we need a text file is enough for us, right? So each service can have their own data store. And infrastructure automation, this ties with continuous delivery, being able to deploy these services automatically, because once you have a large number of services and a large number of teams, this automation is key, right? So you should be able to continuous delivery or continuous deployment in a way that all these services work together well. Evolutionary design, which means you can replace each microservice. So the implementation can be changed at any time because these services are independent. So you just have to keep the API contracts between services working, which means today you're writing something in Java, tomorrow you write it in Go. It doesn't affect anybody as long as you keep the APIs. So that's the service agreement. And definitely designed for failure. So when your service is going down for whatever reason, because bad things are going to happen all the time, there's some things that failures you cannot be prevented. How do you make this service survive? How do you make this service come back online? So you have to design for what's going to happen if a service I depend on is not available at the time. There's a really good article from Martin Fowler talking about microservices, because we hear all the good stories about microservices, Amazon, Netflix, all these companies doing it. But it's the comparison he does is like, you gotta be installed to write microservices, right? You have to have rapid provisioning. So if your operations people takes 1 month to give you a server, this is not gonna work well for you. So this is mostly cloud-based or private cloud where you can get machines using APIs. You need monitoring. And you need a rapid application deployment, continuous delivery, which kind of ties into DevOps culture, where everybody works together, developers, testing, operations, towards a common goal. So it's not like I throw something over the wall to operations and then I wait for them to give me a server. That model is not going to work. And there's also the Conway's law, which basically tells you that the design of a system will be a copy of their organization communication structure. So if tying back to DevOps, if you have teams that are fighting over each other, turf, and saying, oh yeah, I'll blame developers because they gave me something that is broken, and developers blaming operations, oh, the thing went down and because they changed the operating system or whatever. If that's how your organization works, that's how your architecture is going to be built. Like developers on one side, operations on the other side, that sort of thing. Continuous deployment, so everybody talks about developing, building, testing, and deploying, automating all these parts, like this is like 90% of the things that you need to be automated. But there's also the other 90% of the things, which is monitor, reacting to problems, and preventing problems. So this is only done by automation, and I could not get tired of saying that you need automation. And there's this great quote by DevOps Barat, to make errors human, to propagate error to all serve in an automatic way is DevOps, right? So once you have it automated enough, I could tell you some stories, but I would have to kill you afterwards, on how you can deploy something that basically breaks. You can have automatic deployment, break something that breaks your automatic deployment, so you cannot fix it with your automatic deployment. But that led me to another quote that I came up with, like, if you haven't automatically destroyed something by mistake, means that you are not automating enough. And again, we can talk about this off the record. So getting into more details on how you actually do this, how you can make it safer to do continuous delivery, continuous deployment. So if you don't want to have downtime when you are continuously deploying things, because obviously if you're deploying once a month, once every 6 months, having a downtime of 5 minutes, it's okay. If you are deploying continuously every hour, every 2 hours, once a day, and multiple services at the time, having 5 minutes per deployment per server is probably not gonna be good. Depends how picky your clients are. So there's some options like blue-green deployment or canary deployment. Anybody doing any of them? Yes, like 4 people. So blue-green deployment, this comes a lot from the web side of things, right? Web deployments. Not everybody of us are doing web deployment, but you get the idea, and this can be done with other, just not web-based properties. So on a blue-green deployment, you have a cluster running, the green cluster, and you have a router in front of it, and then you have your version running, and then your user goes to the current version, okay? When you deploy a new version, and I don't think I have the animation. No, okay. When you deploy the new version, you deploy it to the blue servers. So now you have two versions running on production, one on the green servers, one on the blue servers. And your user, at some point, you can test that the blue servers going through a private URL or private API and check that everything is fine on the blue servers. And then at some point, you basically switch in the router and say, OK, send all the users to the blue servers. So you point to the blue servers. If you find there is a problem, you can just easily roll back to the green servers, to the previous version, by changing the router again, right? So it's a very easy way to do deployments without risk, right? Continuous delivery is all about making things with less risk. Because if you have risk, the best thing you can do is do it more often. If you have deployments, if your deployments are painful, just try to make them more often, try to automate things, and then they become less painful. This is one way to reduce the risk. And if you go to anybody and say, hey, instead of deploying over the old version in a way that we can never roll back, and we'll do it this way, they will come to you and say, like, yeah, well, this is probably a good idea. At some point, you'll have to talk about how you operate the router, but that's for advanced discussions. The other option, canary deployments, is a similar concept, but in a different way. So you have green servers running 1.0, blue servers running 1.1, and you start sending some of the traffic to the new version. So this is how Facebook, Google, I mean, you name it, they do it. They start rolling people, like in New Zealand, 10% of the users, or whatever number they come up with, to the new servers. If they see an increased rate of errors, they just roll back by switching the router again to the old version and stop the deployment and look at what happened. But if nothing bad happens, they just keep sending more and more people to the new servers. So it's a mix of like blue-green that gives you even more safety, right? If something is wrong, you point it to the back servers, and only a few percentage of your users have noticed that. Obviously, this is not trivial to implement, but you get the idea. Now, a key thing to get this working is that monitoring is the new testing, right? It's no longer good to just, oh yeah, I run it, I have my unit tests or my integration tests, I run all of them, it works. Now you deploy it, and users will find a way to break things in new and very interesting ways that you never predicted. So that's why monitoring is really important. You need to know whether your application is running, whether your application is serving errors, whether a user is not able to reach it. All those things, if you have monitoring, that will prevent you from having breakages that last a day into having breakages that last a few minutes, or depending on the severity of them. So use data for monitoring, take proactive actions, not only after the fact, but you can also take actions before something bad happens. So if you are running out of capacity, but you have monitoring, look at that and know, you can even do this automatically. scale your cluster, get more resources automatically. And the cloud providers will do this for you fairly easily. And you have, so this would be like auto-scaling. Auto-scaling also brings new and interesting problems. So an example of things we have done in the past, like using AWS, where you supposedly have infinite capacity, right? And you just request servers, and Amazon will happily build you for those servers and give them to you. Well, not always. We realize, well, you have in Amazon you have like resource limits. There's so many virtual private clouds or that you can do, number of snapshots, instance sizes that you can request. You are limited, and you also have rate limits that affect the whole account. Like we were doing some testing. And then one of our services was requesting too many snapshots very concurrently. So we have like 20, 30 servers requesting snapshots continuously. And Amazon basically starts giving you errors saying you exceeded your rate limit. The interesting part is like, oh, this is not just affecting this service, this is affecting the whole account. So other people that were developing on that account realized that their stuff was not working anymore because they were also getting the rate limit exceptions. You are making too many requests to the API, and then your account is basically down. So first advice, if you use AWS, use separate accounts for different things. Yeah. So, and you can also, and you have to retry because basically you have to assume failure can happen anytime. And especially in a cloud world, you have to retry things if your APIs are giving you errors, but make sure you do an exponential backup so you don't hit the APIs too often. Pets versus cattle, if you heard this, treat your servers as cattle, not as pets. If your server dies and you have a problem because it's your little server that has all your stuff and you treat it with care, you make sure it's always running. If you cannot survive like a server crash, then you have a problem. And treat them as cattle, right? If one server dies, well, you have another one to replace it. And there's another quote from Kelsey Hightower, he works at Google now, like how would you design your infrastructure if you couldn't log in ever? So if you don't have SSH, and I'm like this close to say, do not even enable SSH in the servers at Amazon or anywhere, it makes you think on different ways. So how can I automatically deploy things? How can I diagnose errors, right? Without me going into the terminal and looking around and what happened, right? So this would be like an end goal that you should go for. Stateful services in a microservices world, they're hard. Like if you have data and your service needs data to work, this is gonna be generally a problem. So you have to think hard about how to solve it. And things like, if you have to deploy your services in a specific order, that's also a problem because what if your service goes down? When it comes back up, how would it reconnect to the other services? So if you're finding yourself deploying things in a specific order, like first database, then web interface or something, you are doing something wrong. Because what if the database goes down? What's going to happen to the web server? The web server needs to account for that and make sure it doesn't blow up. Those are the types of things you have to have into account. Right. So, and that comes to the concept of resilient or self-healing systems, and where your services have to adapt to errors. Because, as I said, if your database is down, what are you going to do with your web interface? Are you just going to crash it? Are you going to just return a 500 error to the user? What's the expected solution there? So what should you do? Send an alert and fail fast like crash? or just keep trying to reconnect to the database? Well, you should try like a mix of both, where your service will send you an alert so you are aware, but will also try to reconnect. Because if the database crashes because the server it was running crashed, but you have automation to move it to another server, when that server comes back up, it should reconnect, and you shouldn't like lose a night's sleep trying to fix it. There's no single cause in complex systems. Don't try to look for it. Again, use monitoring, try to figure out things as they happen, try to avoid them in the future or prevent them. Embrace failure. That would be the key takeaway. And I have a couple of slides here about chaos engineering. Anyone familiar with chaos engineering? Yeah, some people. So this came from Netflix, where they built the Chaos Monkey, basically a service that would kill random servers on their clusters and check that everything was still working. So this is a great way to test on your running production systems. And related to this, they built several tools that you can use for basically checking that what if a whole availability zone in Amazon goes down. So this is what happens when you see Amazon going down. The first thing you go and check is like, you go to Netflix. If Netflix is running, the problem is yours. If Netflix is not running, the problem is Amazon, okay? So, because they use multi-availability zones, multiple regions, and so on to deal with Amazon failures. And, well, and containers, Docker. Who's heard about Docker? Who's using Docker? No? Never heard about it? Yeah. Get out of that cave. And so Docker has popularized how to implement microservices, right? You create your containers talk to each other, and so on. And we can, if you want to find me later, we can talk about containers. Just try to not make it like Docker is the solution for everything, but it's probably for 90% of the cases. Don't quote me on that. But containers are not trivial, and there's issues with cluster orchestration. So it's great to have Docker running on one machine, one host. Everything works, but then when you start to moving into clusters and multiple hosts and multiple Docker instances, that's where things like Apache Mesos, Docker Swarm, or Kubernetes clusters will help you and will automate a lot of stuff for you, like auto-scaling, resiliency, self-healing, all that. So that's it for me. Vala, thanks for having me.